Welcome to the Deep Dive. I'm Christian.
And I'm Vanessa. We're both software engineers here at CodeSport Labs.
Yeah, we're a tech incubator and makerspace,
Mm.
really digging into things like AI, fintech, and blockchain.
You can check us out at codesport.io.
So today we're diving into digital security and modern authentication methods.
That's right. We're drawing heavily from a couple of really insightful blog posts written by Marcos, one of our senior software and security engineers here.
They're great reads.
Definitely. You can find them on the CodeSport Lab site. One is passwordless authentication, phishing, and bypass-proof MFA.
And the other is Security 101, the 5 pillars. We'll link those URLs in the description, of course. So codesport.io, passwordless.authentication, and codesport.io, Security 101. You'll find them.
Our goal today is basically to unpack how these newer authentication methods are fighting back against, well, the biggest cyber threats we see now.
And grounding it all in those fundamental security principles Marcos lays out.
Exactly. So maybe let's start there with the foundations.
Makes sense. So in Security 101, Marcos talks about the 5 pillars of information security. These are confidentiality, data integrity, availability, non-repudiation.
Okay.
And the 5th one, which is super relevant for us today, is authentication.
Right. Authentication seems key. Marcos really emphasizes it. How does he define it simply? And what about those factors?
Yeah, authentication is really just about being sure, like really sure, that the person or system you're talking to is actually who they say they are. It stops impersonation.
Got it.
And the 3 factors are the classic ones. Something, like your password.
A knowledge factor.
Exactly. Then something you have, like a security key or maybe your phone with an authenticator app. That's possession.
Okay.
And finally, something you are. Think biometrics, fingerprint, Face ID. That's inference or inherence, sometimes people call it.
Okay, so we've leaned heavily on that first one, knowledge passwords for ages.
For way too long, probably.
Yeah, and Marcos argues in his passwordless post that passwords and even those time-based codes, the TOTPs from apps, they're just not cutting it anymore. Why is that? What's changed?
Well, the threats have gotten much more sophisticated. You've still got the usual suspects. Keyloggers, malware stealing things, database breaches, exposing passwords.
Standard stuff.
Right. But the big one now is adversary-in-the-middle attacks.
ATM.
ATM.
Okay.
Yeah, people use tools like Evil Jinx or Sneaky Log. These things can basically sit between you and the real website, grab your password, and grab your TOTP code in real time.
Wow. So even if I have 2FA with an app, an ATM attack can potentially bypass it.
It absolutely can. It makes that second factor way less secure than people think. It's just not phishing-proof.
Okay, so if the old ways are broken, what's the fix? Where do we go?
Well, this is where the FIDO Alliance comes in, FIDO.
Heard of them?
Yeah, they've developed standards, basically a whole suite of tech, designed to make authentication genuinely resistant to phishing. And often, it lets us get rid of passwords entirely. It's all built on public key infrastructure, PKI.
Okay, PKI. And we hear these terms thrown around U2F, FIDO2, WebAuthn. Can you sort of map that out?
Sure. So U2F, Universal Second Factor, was kind of like FIDO version 1.0. It used those physical USB keys, like YubiKeys, as a second factor. Good start, but it's been largely superseded.
By WebAuthn.
Exactly. FIDO2 is the overall project, and WebAuthn is the key standard within it. It's the browser API, the piece that lets websites actually use this strong authentication.
And it gets rid of passwords. How?
It uses asymmetric public key cryptography. When you register with a site, your device creates a unique key pair, a private key stored securely on your device, and a public key given to the website.
Okay, so the private key never leaves my phone or computer.
Never. That's the crucial part. When you log in, the website sends a challenge, your device signs it using the private key, proving it's you, and sends the signature back. The site verifies it with your public key. No password needed, and crucially, it's not vulnerable to phishing or replay attacks because the signature is tied to that specific site.
That makes sense. It's like a unique digital handshake only my device can perform for that specific site.
Pretty much, yeah.
So then, passkeys. This feels like the newest buzzword. Where do they fit?
Right. Passkeys are basically the user-friendly implementation of WebAuthn credentials. Think of them as discoverable credentials.
Discoverable.
Yeah, meaning the website can see you have a passkey registered for it, often tied to your account, so you don't even need to type a username. They're stored securely, often synced across your devices using things like your iCloud keychain or Google Password Manager.
Ah, so it's WebAuthn, but smoother, synced, and potentially no username entry needed.
Exactly. You just use your device's unlock method, Face ID, fingerprint, PIN, and you're in. It completely replaces the username password flow in many cases.
And that ATM resistance we talked about, how does that work with passkeys or WebAuthn?
It's built in because the authentication challenge from the website includes the website's origin, like its domain name. Your device cryptographically binds the signature to that specific origin.
Meaning,
If you accidentally land on a phishing site, mybank.feek.com instead of mybank.com, your device knows it's the wrong origin. The signature it creates won't be valid for the real mybank.com server.
So the fake site can't relay your login, that cryptography stops it cold.
Precisely. It neutralizes that whole ATM attack vector. It's a huge step up.
That is significant. And for developers wanting to implement this,
It's getting easier. There are libraries available. Marcos mentions a couple like Albus WebAuthn for PHP developers or Simple WebAuthn for the Node.js TypeScript world. They handle a lot of the complexity.
okay. So wrapping this up a bit, what does this all mean for you, the listener?
Well, understanding this shift is pretty vital, whether you're building apps or just trying to stay secure online.
Yeah, we've gone from those basic security pillars through the problems with passwords and even basic 2FA, right up to these really robust phishing-proof solutions like WebAuthn and passkeys.
And adopting these standards is becoming really important for any service that handles sensitive data, finance, enterprise tools, anything where security is paramount.
Yeah.
It's about better security and often a better user experience, too.
Definitely less friction than typing passwords and codes all the time.
For sure.
So here's a final thought to leave you with. As our digital identity relies less on what you know, passwords, or what you have, tokens, and more on who you are, biometrics tied to secure hardware, what bigger shifts might we see in society? How did that change our concept of identity online?
Interesting question. Lots to think about there.
Absolutely. We really encourage you to check out Marcus's original blog post over at CodeSport Labs for a deeper dive into all the technical details.
Definitely worth the read.
Thanks for joining us today.